So if you weren't here last week when we started this up, don't worry because I'm going to go over stuff again last week. But we had a lot of questions last week too, which was good. So the first thing I actually want to do is there were two questions asked last week, and I want to sort of give better answers or explain more. And one of the questions I was actually wrong about. So it's okay to be wrong. I was wrong last week. So the first question that I'm going to go over again was JJ had asked about in Exodus when God says God changed his mind. He was going to kill the Israelites because they worship false idols, and then Moses sort of pleaded with God to spare them, and it says God changed his mind. So, we sort of discussed it, had a couple different explanations for it, but I sort of looked into it more and wanted to talk about it a little more. So there's a couple different things. The Hebrew word there is nasham, and it's spelled like this. And that's the word that's changed. But this is translated a bunch of different ways, and it's most commonly translated as relent, like God relented, God relents. It's also translated sometimes as comfort or comforter or ease, but it can be used as change. So that's one way. I always sort of like to look to the original translations or the original word. These words don't. It's not like it has a literal. Here's the word in Hebrew. Here's the word in English. These languages are complex. But I think also that the best way to think about this and the best way to look at this, as I said, the Bible is a narrative. The whole Bible sort of tells the story of sort of God reconnecting with his people and giving us a way to salvation. So the Bible is literally a story, I think, about Jesus, even the Old Testament. So I think this is a representation can be interpreted as that Moses is sort of the Christ-like figure in this story, that just how Christ intercedes for us on our behalf, Moses was interceding for the people. And it sort of is a representation of that in that story, that God sort of, the law is given, and he didn't say he was going to kill the Israelites. The law was given, and then it's shown that the punishment for sin or the consequences of disobeying the law is death. But however, God's grace is still greater than the law, and I think that's sort of an illustration of that. And that in multiple times in the Old Testament that there are sort of things that represent, I think, Jesus in the Old Testament and the way that relationship was. So that was that question. And I said the other way to look at it is just there's a multitude of meanings to that word. And also, if you look at other stories in the Bible, God always sort of waits. He sort of waits till we do something, and then there's sort of reaction, even though he sort of has the knowledge. He knew Adam and Eve were going to sin, but yet he still waited till they sinned. He sort of gives us the chance, I think. It's the same thing with Abraham. He promised Abraham a son, but then Abraham just went ahead and God still waited and God still kept that promise. So I think there's a lot of different ways to look at it. The other question was from Jerry, who's not here, but we were talking about the universe, and he said he thought the universe was infinite, and I sort of said no. And I don't think I explained that properly. When I said that outside the sort of physical universe, there is nothing, that's not true. It's just that we don't know. And it's not that we don't know because we can't see. It's just that it's sort of beyond space and time. When they say outside the observable universe, that just means that it's not something that we can measure or see. It's not just that we don't see that far, or we don't know. We can still detect the radiation and stuff like that. So I wanted to sort of give a visualization of the universe. Again, and this is, so picture I think Jerry especially, I think people picture here's the universe, and you have galaxies, and here's maybe our galaxy, and they sort of look at they're looking at a map. This is a bad way to visualize the universe. So because they think, you say the universe is expanding, they think it's just sort of getting bigger and we're here somewhere. That's not actually a good way to visualize it. Better way to visualize it is think of a balloon. So imagine a balloon, and imagine you have galaxies on the balloon. Now imagine this is three-dimensional. So you have a three-dimensional balloon, and all the galaxies are sort of on the surface of the balloon. And so when they say that the universe is expanding, the balloon is sort of growing, and all the universes on the surface are sort of expanding that way. So it's like at any point in the, early astronomers thought we were at the center of the universe because when you look out, it looks like you're at the center of the universe. But if you traveled to like the next galaxy, you would still look like you were at the center of the universe because it's expanding this way. So anywhere you are, everything is sort of expanding in the same distance away from us. So I wanted to explain those two things. Again, if you weren't here, you're probably like, why are you talking about this? So as I said, we're going to just go over like one argument this semester, and then we're going to get into a doctrine, and then we're going to talk about evolution. So we're starting with what's called the teleological argument. We discussed this last week, and this is sort of an argument from design, but it is not to be confused with the intelligent design theory. I said I'm not really going to talk about that theory until later. But again, I will say, like, I'm not a fan of the intelligent design theory. What the intelligent design theory tries to do is it tries to give a scientific explanation, like, for a designer. Like, this argument is a philosophical argument. Like, I don't actually think that God can be proven like by the scientific method. And sort of intelligent design tries to do that. The problem with that is that you can't really call it God. Like, if they discover that aliens sort of created human life, that again is, take a little pause. Just got a hard head. It could be any type of intelligence, so like aliens could have created human life, and there you go. That's an intelligent design to life. I think that the discussions of the existence of God are in the realm of theology and philosophy, not sort of science. I think science can then sort of, as I said, point in a direction, but it can't be scientifically sort of proven. You can't apply the scientific method to God. So that's why I don't really like the intelligent design theory. Tries to put itself right next to other scientific theories like the theory of evolution and put it on that level. And it's like the arguments for the existence of God are in a different field than evolutionary biology. Those two things are separate. So that's why I don't really like it. So this is a philosophical argument for design. So last week I talked about what was called the fine-tuning of the universe. And what this basically means, I'll go over it again, is that the universe has these qualities to it that they don't really have an explanation for. So at the beginning of the universe, there was these arbitrary amounts or arbitrary quantities, like the amount of matter, and there's no sort of scientific law or law of physics that determines that amount. It was just sort of there at the Big Bang. I talked about that level of entropy was at a certain level at the beginning of the universe, and if you weren't here last week, that just means the level of disorder in the universe was at a certain level. And then you have these things called constants, like the force of gravity is a constant. It's been there. It's not determined by a physical law. You have all the forces, the weak force of the atoms, like the things that hold atoms together, and that there's this force. They call it the strong force, and it's just there. It's not determined by a law of nature. So these things are called the fine-tuning of the early conditions of the universe. When we say fine-tuning, we don't mean that they're tuned. It just means that they are such a precise amount that it's they fit into this narrow range. So as I said last week, I lost my pen already. No, this one. The one I was drawing with. Oh, here it is. As I said last week, for example, that the constant of gravity is, if it was, how did I word it? So if gravity was any different than this number, so basically this number is the number 10 with 80 zeros after it. And if gravity was different by one part to this number, it wouldn't be possible for life to exist in the universe. We have other numbers like I think it was the force that holds atoms together. If it was different by one part in 10 to this number, it's 10 to the power of 100. Again, these numbers are hard to visualize, so imagine 10 with 100 zeros after it. So if you're thinking about that as a percentage, it would be like 100 zeros, 1%. Like if the force of gravity or the weak force of the atoms. And so these are what are called constants. And these things aren't determined by physical laws. There's no law of nature that says like, oh, this is what causes gravity. It's just there. It's just there at the beginning of the universe. So as I said, like you can, we're not even talking about changing the laws of nature. You can just have these set laws of nature and you just change these amounts and it changes the possibility for life to exist or not exist. So we sort of had this discussion about, think of all the different, possible universes you could have, and the amount of them that would be life permitting is incredibly small. So what I want to talk about now is there is the argument on the paper, but I said we're not going to sort of go through the argument premises. It's just if you wanted to have it. We're just sort of going to talk about this fine tuning and what could sort of be the cause of it. Like, why is it the way it is? And so there's sort of, actually, before I get into that, what I want to say is this is sort of almost universally accepted in science that our universe is fine tuned. And when I say that, like I said, I don't mean it's tuned by a tuner like a person. It's just the prerequisites for life to even be possible to exist are like so infinitesimally small. Like, and this is even to, like I said, even like to form stars, to then form planets, to even begin the possibility of life to then start evolving is like incredibly small. I think Bill has a question.
Thank you. This is because the universe is intimate. Infinite. If it was...
no, the universe is not infinite.
If it was finite, then you're limiting the amount of places where life could exist.
No, that's not. That's I see what you're trying to start to ask. This is the universe as a whole.
Right.
The universe that we live in. It's not like the number of places where life might exist. This determines that like life wouldn't be possible anywhere in the universe at all if these numbers were off by like anything. Like, so not just like, oh, it's possible for life to exist on this planet in this solar system. It's anywhere in the solar system.
But you're talking about a finite universe when you're using these numbers.
Our universe is finite, the one we're in right now.
Okay, but if you took the opposite tack and thought that the universe was infinite, then could be.
We'll get there.
Okay.
We're gonna get there.
I'm always one question, man.
So as I said, there's only a very few people who sort of deny the fine tuning, and they're usually philosophers, not scientists. So there are some. So what are sort of the reasons for this fine tuning? Like, why is our universe so precisely fine tuned to this level? So we have three there's three prevailing sort of reasons. There might be a fourth reason at some point, but right now these are the three dominant. One is called physical necessity, and this is sort of the least accepted one because it's the most really improbable. I'll write it down. What this just means is that the universe is life permitting because it had to be. Like, it's necessary that the universe is life permitting. Like, here we are in a universe that has life, so then it had to be that way. We talked about this 2 years ago about sort of things being necessary. And I talked about that the universe isn't really necessary. Most scientists won't accept that. I mean, it seems like very improbable that just because our universe is life permitting because it's impossible for it not to be that way. That just seems like a very improbable thing. That the constants and quantities began, like when the universe started, the constants and quantities were the way that they were because it's impossible for them to be any different. Like, so these numbers that I had up there, like, don't matter because they couldn't be any different number. And again, that isn't really accepted. It seems very, very like implausible that that would be the case. Remember, if you can think back, I talked about necessary versus contingent things. So this would be a necessary thing. And, you know, mathematics can basically formulate other universes that operate differently. So it just seems like, you know, it wouldn't be a necessary thing. You may have heard of something called the theory of everything. And you may think like, oh, that really doesn't have to do with this. Some people bring that up, you know, when talking about this, like, oh, what about the theory of everything? There's all these theories that have weird names that don't really have anything to do with what, like, you may have heard of the God particle. Like, it's just a weird, it's just a subatomic, it's the smallest known particle right now. They called it the God particle, but it's like the Higgs boson is its official name. And it's just, you know, you have atoms and then electrons, protons, neutrons, quarks. And this is just a new particle that they discovered that's even smaller. And it's, for some reason, it got coined the name the God particle. There's even like a movie based on like how this is going to destroy religion, yet it had nothing to do with science. Just the name of the particle. So again, the theory of everything is another one of these things. It's not the theory of everything. Yeah. The Higgs boson is everywhere. Just like atoms are basically everywhere. But even in empty space, in outer space, is filled with the Higgs boson particle. It's sort of like, imagine if, you know, a fish doesn't know it's in water. Imagine like you could create an air pocket, and then sort of this Higgs boson is basically the nature of reality. Like, it's almost like there's this field, and like without this field of this particle, nothing could exist.
Is it mass?
No. Well, no. It determines mass. Like, so, you know, you have protons, electrons, and neutrons, and they don't have any actual size. Like, they don't actually, they can be measured, but they don't have size, but they all have different masses, which is like weird because we think mass is related to sort of size. The reason they have different masses is because of the Higgs boson particle gives them different masses. So again, I don't want to get too far into it because like this already is as complex, too complex.
I'm not an actual physicist, so it's a little difficult.
Yeah, I mean, quantum mechanics is weird. It's weird stuff. So the theory of everything is basically like, I talked about gravity and the weak atomic force and the strong atomic force. And then you also have electromagnetism. These are like the four fundamental forces we know about in the universe. So you sort of know what gravity is, you know, sort of what moves planets around, galaxies around, what keeps us on Earth. And electromagnetism is the thing, you know, you have the North Pole, the South Pole. And then you have the two atomic forces, which is what keeps atoms together. So what they're trying to do is reduce this down to one force. They're trying to discover because these forces aren't related. They're not related. They're like, why is gravity this way and then this force is this way? So they have this thing they're calling the theory of everything that's trying to unify those four forces. But they haven't, it's not, you know, it's just sort of what they're trying to do.
Is that Stephen Hawking? Is that
That's string theory is part of that, you know, M theory. But yeah, he coined it, the theory of everything. I wanted to bring that up. So again, physical necessity is sort of like the weakest explanation for this fine tuning. The one we're mostly going to talk about today is chance. And this is sort of what Bill was hinting at. So why is the universe so finely tuned to be able to support life? Chance. You know, could it just be the result of chance? Like, you know, we just got lucky. Like, here we are, we're alive. You know, we can't really deny that. So again, it must just be, that's how it happened. We just lucked out. Yes, all these numbers, it seems beyond probable. You know, I even talked last week that even one of these numbers is like what, you know, they say it's like if you go beyond that, it's actually a theoretical impossibility for that to happen. But it did. So again, even though it's an incredibly remote possibility, it just happened. So, you know, you often hear comparisons when scientists or philosophers are discussing this, that it's like we won the lottery. We won the universal lottery. Like this one universe, we just happened to win the lottery. So they'll say, let's imagine like a lottery where every possible ticket is sold. So like there isn't a number that's not picked. Every single possible number is picked. So someone is going to win. When the number is drawn, someone is going to win. So just because when the number is drawn and that person wins, we don't think that it's like, oh, it must have been designed that one specific person won. It was just they won the lottery. So like the universe is here, so we just won the lottery. Like there's no reason behind it. You know, it's just like that. Like that one person wouldn't think like, oh, like they might think like, oh yeah, I got so lucky, just like we got lucky. We have this universe. However, this is a false analogy. The reason it's a false analogy is because we're not asking why this universe exists, but we're asking why it is life permitting. So I want to give a different sort of analogy that's in the same vein and sort of show why the other one is a little wrong. So, you know, you've seen those lottery ball machines, like, you know, all the balls are spinning around and the ball comes up and they pick the number. Got the lady there. I forget her name. Yeah, there it is. So let's imagine something like that, but that's like really, really, really big. And it's filled with, so let's say Dave. Dave is playing, called the Lottery of Life. So he's got this big, huge, you know, lottery ball machine filled with like billions of balls, like billions of white balls. And there's one orange ball, just one. Now, one of these balls is going to be picked. You know, that's inevitable. Like one ball is going to be picked. And this is just like with that first analogy. Like, yes, one person is going to win. One of these balls is going to be picked. So we know that's going to happen. Now, if any ball but the orange ball is picked, Dave dies. So he got one orange ball in, let's say, like 7 billion balls. And it comes up, and it's the orange ball. I'm like, oh, okay. Well, maybe Dave lucked out, like 1 in 7 billion chance. Now, let's imagine it's got to be picked 9 more times in a row. 9 more times the orange ball comes up. Now, multiply that by trillions. Let's just say Dave's got to get that ball, orange ball picked 1 out of 7 billion. It's got to be picked orange consecutively like trillion times in a row. Like, do you think that would just be luck? Like if that happened, that's not luck. That's a statistical impossibility. That's what we're talking about when we're talking about the fine tuning. Yes, a ball gets picked. Yes, a universe exists. But then why is it a life permitting universe? Why is Dave's life spared? The analogies are different, you know. So that's sort of one way to respond to that. Now, another thing they'll say is there's this thing called the anthropic principle. I'll write that down. This is under chance. Now, what the anthropic principle is that it's sort of hard to explain. That there is no explanation needed for why we observe a finely tuned life permitting universe, because it is the only kind of universe that could be observed. So if this universe wasn't life permitting, there'd be no living observers to observe it. So we shouldn't be surprised to see a finely tuned universe, because that's the only kind of universe that would support life. So something that's been sort of presented, you know, again, in the field of philosophy and science. I think it was more philosophers started this. But again, I think this is also a fallacious reasoning. It's like the fact that we can only observe a life-permitting universe doesn't have anything to do with like explaining why it's a life-permitting universe. A good way to sort of illustrate this analogy is this was from Hugh Ross. So again, we'll use Dave again. I like using Dave for my examples. So let's say Dave goes to like a Middle Eastern country and starts spouting off at the mouth. And he gets arrested. He gets arrested and convicted of some, religious crime, and he's going to get put to death. because that's what they do over there. They don't just be like, no, you shouldn't do that. They put you to death. So like, let's say he's standing before, a shooting squad of 100 marksmen. These are like the best shooters in the country, 100 marksmen. And they all shoot. They don't even give him a chance to say any last words. And he doesn't get hit. Now, would you say like, well, I observe I'm still alive, so I guess there's no explanation of why I'm still alive, because I can observe it. No, that's not what you would say. I mean, it's true that you wouldn't be surprised that you don't observe that you're dead, because you can't observe that you're dead, because you'd be dead. However, you should still be surprised you observe that you are alive. Like if 100 marksmen miss at like a shooting range like that, you would assume that they missed on purpose. You'd assume that they didn't, or it was a miracle, But there was some reason why they missed. There's some explanation. You get it? Does that sort of make sense? That's sort of like a good response to the anthropic principle. Like I said, it's sort of it's even weird to think, like just because, we're here to observe that we're alive, so then therefore the universe doesn't need an explanation for why it's life supporting. It's just doesn't make sense. So doesn't mean Chance is dead, Bill. Don't worry. We're still here. So as the best scientific evidence shows right now, our universe is not infinite. It is about, the science shows that's about 13.5 billion years old. Again, this is not a Bible class right now, so whatever you might feel about the age of the universe, just put it aside for now. We're talking about science. So, a couple in the century ago, they thought that the universe was infinite, and that's why they didn't really have a problem. They were like, there's been an infinite amount of time, so life eventually just had to arise. So now we know that that's not true. So now you have this hypothesis that is called the many worlds hypothesis. How do I spell hypothesis? Yes. You may have heard this word more commonly referred to as the multiverse. Basically what this is that our universe is just one of many universes in this sort of giant collection of universes. And that even this multiverse is an infinite number of universes. If you're a fan of Marvel movies or DC superhero movies, they have a multiverse, all these different worlds, all these different universes. It basically, to help the chance explanation, this multiverse is infinite. So there is an infinite number of universes with an infinite number of constants and amounts, even maybe different laws. Like there is just an infinite number of universes. The amazing thing that to me is that this is the sort of prevailing discussion and debate to explain fine-tuning in the scientific world. That they are discussing this many worlds hypothesis. Some people will call this the God of the atheists is the multiverse. The reason they say that is because this is based on faith. There actually is no scientific evidence of the multiverse. We have no evidence of a universe outside of our own.
I once read that the multiverse theory, that one scientist kind of compared it to like sand on a beach. So he said each particle of sand is like its own universe, and so all these universes make up this whole beach. But then I kind of started thinking about that. I'm like, well, then in reality there is a universe, right? Because the beach is finite, so there's just lots and lots of universes within a universe.
Yeah.
Right. So there is a finite universe still.
You're getting to one of the responses to this.
Oh, okay.
No, that's fine.
Yeah.
But yeah, you're sort of leading to one of the responses to this. A study by, I should have wrote down his name, but a study by a sociologist, he went around and asked he asked a majority of the current cosmologists and astronomers today, these are the guys who study the universe, And he basically asked them a question. The question was, he didn't ask them what they believed, but he asked, do you believe that the many worlds hypothesis is a prevailing theory right now because it is a way for these scientists to reject design? And the response was about 62% said yes, that it wasn't based on science, it's because they don't want to accept the possibility of a designer. So again, here are some responses to the multiverse. And this is like, I'm going to assume the multiverse is real. Like, let's hold on. Question first. Need the mic.
Ben, how long has this multiverse hypothesis been around?
Started in the 50s, but it started differently. There was this scientist called Boltzmann, and he was sort of trying to explain the beginning of our universe, like how it sort of could seem to come into existence out of nothing. And he sort of tried to come up with this hypothesis that there was sort of this bigger universe with sort of these particles colliding and exploding, and one could cause this massive explosion that then caused like our universe. So there must be a bunch of them happening. The way he sort of laid his theory out has sort of been rejected, but now that's been picked up over the last probably 20 to 30 years, this hypothesis.
Because I thought the word universe entailed everything. I thought.
No, I mean, universe, it just means, it's like we say, it's like all of our space-time reality. So universes, if they did exist, would be a separate time, separate space, just like it's not that there's another universe that's around next to ours at the same time, like time is relative to our universe. So, now I forgot where I was. Okay, so let's assume this is true. Like, let's assume the multiverse is a true thing. There's still responses to someone who says this. Just like our universe is fine-tuned, how do we know that then the multiverse is not fine-tuned? Like, there has to be some mechanism that generates these universes. There has to be some laws that this multiverse operates under, that you have these expanding universes. And the assumption now too is the multiverse operates a lot like our regular universe, that it is sort of expanding and there's universes in it that are expanding, because we know that our universe is expanding. So if you had this sort of like area of other universes, our universe would then just like collide with another universe because we're expanding. So they sort of assume that all these universes are expanding. So they're making an assumption it operates under laws, like the multiverse operates under laws, but then what then dictates these laws, dictates these sort of amounts. Again, you run into the same problem of the fine tuning. You just sort of step it back one, This leads to what is called, like in philosophy, an infinite regress. Like, you can always just push the question back ad infinity, whatever answer they come up with, like, oh, maybe the multiverse is part of a grander multi-multiverse. That's not an answer to the question. It's just pushing it back, and then the questions of like, does the multiverse have a beginning? And if it had a beginning, we can go back to the first year where we talked about our cosmological argument for God. If something has a beginning, then it needs to have an explanation for its beginning. So what was the explanation of the beginning of the multiverse? So that's one response. Another response is, as I said, this isn't actually a scientific hypothesis. There is no evidence for this. This cannot be observed by the scientific method. That's why, again, it is left to the discussion of this class, like discussion of it's a philosophical thing. Scientists treat it as a hypothesis, but they have no evidence of it. They can't examine it. They can't study it. We can actually observe in theoretical ways the beginning of our universe. There's radiation we can test and we can study, and that's how we know scientifically all these things. This multiverse, we can't. We don't have any of that. It's all just sort of assumptions. There's no evidence. George Ellis, who is a leading cosmologist right now, is someone who says this. He says this hypothesis is not capable of any scientific proof. The other problem is there aren't actually philosophical arguments that really support this. Like I've given a lot of philosophical arguments for like support the existence of God. I'm not saying they necessarily prove God, but they make belief in God rational. I've sort of laid that out. This is just postulated as an explanation of fine tuning. Like the universe is finely tuned, so this must be the case because that's the only way it could be. That's sort of how they come up with it. The third, and I think biggest problem with the multiverse hypothesis is that it is incredibly more likely if there's an infinite number of universes that we actually exist in a much smaller universe than it appears. Because that smaller universe is highly more likely than a larger universe. Roger Penrose, another cosmologist, he basically says that it is incredibly more likely that the universe is actually only the size of our universe. I mean, our solar system. That beyond Pluto, there's nothing there. You know, and that is much more likely than that we would have this huge universe. He doesn't believe that there's nothing there. He's arguing against this. He's saying that it's more likely that the universe is actually just the size of our solar system. And everything else is just illusion. Again, he doesn't believe that, but that is more likely. Like if you have an infinite number of universes, it is much more likely that we don't live in this big fine-tuned universe. So that means all of our science is wrong, like, and everything, and then you can't really trust anything. The thing that makes this even worse is what's even more likely than that is that you are just a quantum brain and nothing is real. The odds of particles colliding and a brain forming and creating consciousness are more likely than our universe existing when you have an infinite number of universes. So based on this multiverse theory, it is more likely that, I mean, I know I exist, but it's more likely that nothing else exists based on this theory. So again, there's problems with when you try to lead to chance, you know, and the explanation for chance is the multiverse. Because our universe is incredibly complex. The numbers I laid out to you are huge. I'm going to put up, again, I did this last week, but again, if you counted in seconds back to the beginning of the universe, you would count this many seconds. So I'm going to do this. So if you counted a number every second, it would take you that many to get to the beginning of the universe. That's what this number looks like. Remember the number I put up for, that was wrong actually. 10 to 80, I was wrong. This number is the number of atoms in the known universe. So again, this is 17 zeros, imagine 80 zeros. Now, the gravity is 100. So if gravity was off by any number, life would not exist. And you have probably, I think they say 17 to 20 of these constants, and then you have more of these quantities.
Are you saying something would explode if they...
No, so like, all right, I'll give you an explanation. So if the gravitational number was lower, like say the constant of gravity was lower, galaxies and particles would never congeal to form like stars, like because there wouldn't be enough force to hold things together. It would, well, if it was off by maybe one teeny, like you might have things form, but they wouldn't be enough to support life, you know? So that's what it means. Like, or if it was higher, like the universe would collapse in on itself because there'd be too much gravitational force in the universe. That's, like I said, just one of these numbers. No, atom is one of the arbitrary quantities. Like the number of atoms is the arbitrary quantity, and that we have no explanation for.
Isn't there something where, like, if like one number is off, like the entire universe would have been hydrogen? Yeah. Right?
That's the entropy. That's what I'm going to talk about.
Oh, okay.
So the entropy level of the beginning of the universe. Entropy is the level of disorder in a closed system. So our entropy level at the beginning of the universe like I said, nothing caused it. It just started at this certain level of disorder. And you want it to be at a certain level of disorder so change can happen. If everything is the same, nothing will change. And that's what he's talking about. So imagine this number if you can. So this is the odds that our universe started at the level of entropy it was at. So I can't even discuss this. It's 10 to the 10 to the 123. So basically you go backwards. So this number would be 10 with 123 zeros after it. And then this number would have that many zeros after it. Not like 1,123. It would have whatever the 10 with 123 zeros after it, that would have that many zeros after it. That is the odds that our universe started at the proper level of disorder.
Encyclopedia Britannica.
Yeah, more than that probably. And as Adam said, if this number was like, you know, if there wasn't enough disorder, the universe would have just been hydrogen and never changed. Like it would have just stayed hot hydrogen. And that's what Tommy was sort of talking about. So again, so the odds of like our universe just being the size of the solar system is like much more likely than this. That's sort of what I mean by these things. And the other thing is you have to then multiply all these numbers together to then, yeah. So like I said, it's,
Oh, because you're saying there's so many different variables?
there's so many.
That's one variable.
So like you have the subatomic force and gravity are about the same. And so then you have to multiply these together. So then you have, and then I don't even know how to multiply it to that number. And so these are all like the basically the odds of a life permitting universe like existing, like all the things you need, like probability. And there are a couple like probability theorists that say anything greater than this is impossible, and all these numbers are greater than that. It's not consensus, but there are some people who say if anything is greater than 1 to 10 to the 80th power, like it's not possible.
I mean, this is pretty powerful proof, though. Maybe not proof, but this is pretty powerful evidence that it is really, really unlikely that life exists without some sort of non-scientific explanation. Don't you think?
Yeah, I mean that's where this is leading, you know. And
Because, I mean, how can you really...
yes, the microphone.
Like, does somebody just sit under a microscope and count like 1 atom, 2 atoms? And it's all.
Now, like what Linda asked is like, does somebody? It's mathematical for like our universe. Advanced mathematics and advanced physics are so advanced, like they can calculate these things. So they can calculate what's going to happen to the universe if these numbers get changed. You know, they can, and they figure out like the number of atoms because you extrapolate. Like there's an estimated number of atoms in you. Like you figure out how many atoms are in like certain things and molecules, and then you say like you just sort of, we know how much is in our planet, and then you extrapolate to our solar system, and then to our galaxy, and then you come up with estimations. The gravity numbers and stuff like that, they're actually able to test those mathematically. So that's how they know that. Same with the entropy level number. I don't know how they do it, but that's what they do. This is, you know, you ever talk to like some of these guys that are weird.
It's not a machine that measures those things. Literally, it's a mathematical formula.
Well, they come up with a formula, and then you can enter it into a computer, and a computer will spit out this number. The computer will run the models and spit out the number. So I think that's going to be it for this class, but I'll open it up to questions. But again, like I said, it's if you had an infinite number of possible universes, it's much more likely that you're just a consciousness existing alone. Like that's more likely than any one of these things just happening by chance. Yeah, there is no spoon. Hold it a little bit.
Hello.
Yeah, there you go.
This happens to me, everyone, just about every day. Like if I walked out the door and I ran into someone that I met in France 30 years ago, I would say, what are the chances of that happening? 100%, because it happened.
Yes.
Right. So if we're talking about, it doesn't matter how many numbers are, you know, I mentioned the Encyclopedia Britannica, but it's could be 10 times that amount of numbers. So what are the chances, even though they're astronomically small, that we have just the right balance of helium, titanium to create this universe?
These are the chances.
These are the chances?
Yeah.
Well, it happened because I believe you're here. I believe
Yes, we are here.
I'm here. So the chances of it happening, since it did happen, are 100%. Isn't that correct? Just like
You're taught. This is like what I said. This is the anthropic principle that you're talking about. Is that, well, since it happened, then then it must have happened. But again, I talked about the thing with David. Like the number is like me running into a random person. Like that number is so much smaller than any of these numbers. Like yes, it happened. What I'm saying is like, yes, it happens because we're here. But the thing is, we need an explanation. Like I said, chance could be an explanation. That's one of the things I said. I'm saying, what is the more likely explanation? That's sort of what we're talking about. So that's why I brought up the example with Dave. Like if he's standing in front and he's got his name in 7 billion names and he needs to get his name picked randomly 1 trillion times in a row. And if that happened, like you would be more likely to say, well, there was a reason for that happening. It wasn't just blind luck.
So it would be more likely that I would run into one of you people walking out of the church than someone that I met in France
Yes.
30 years
We're
ago.
talking about like probabilities.
Probabilities.
Yes. And
Okay.
like, that's why I said, I am saying chance is a possibility. I'm just saying it is incredibly unlikely. And like I said, it is, like you said, you just talked about like, well, I know you exist because you're here and I exist because I'm here. It's more likely that I don't exist than that this universe is actually real based on probability. Like it's more likely that everything is an illusion than things that exist. If chance is your reason. Like if chance is your reason, that's what's more likely.
So I have a question for you. These are the chances that it could happen?
It's probability. So you could say
Okay,
chance.
because I think that chance and probability are different. If you roll dice, chances are the same every single time you roll it, that 50% chance it could come out 1 again or whatever. But I think the probability is that if you rolled it that time, you rolled it this time, you rolled it that time, the probability changes
Yes.
that you'd roll it again.
Because each time you roll, there's less of a chance.
Oh, I agree with you.
Yes.
So, but I'm saying that that's a different law. It's a law now of probabilities. The
There- I
fact
mean-
is that we rolled once and we existed. In other words, he took it to 100% because we did it once. But I'm just saying, I don't think that the odds change. It's still 1 in whatever Google name you want to give one of those numbers. It's still always that. And now the probability is even higher that it's not going to happen again.
Well, the probability is, yes, you could say that. That's one way
Okay.
to look at it. But like you said, you could say this is a chance, and then this is a chance, and then you have to multiply them. Then you have to get both of those things. But it's all, I see what you're saying. But so you roll a set of dice.
Yeah.
You can say, oh, you have 1 in 2 chance of rolling 1. But you could also say there's a 1 in 2 probability.
Yes.
It's the same thing. I'm trying to get you to like not think of them differently.
He's simplifying. You're differentiating.
Yeah, I'm just trying to simplify it for you.
But to me, probability is different than chance.
I mean,
And I'm okay with it being different. You think it's,
Let's get rid of the dice and go with the coin. We have
Yeah.
50% chance of throwing the heads. But if you throw the heads, after 99 times that you flip the coin, and it's heads every time, she's saying the odds are it's going to be 50% chance of heads coming up, but the probability is it's going to be tails. That's what she's saying.
yeah.
but I think you could also say chance. I think you could use chance there, but you can just word it the way you want. You're right. You're right.
You know what that means?
Yeah.
For marriage. You gotta say that.
Ben, you mentioned gravity, electromagnetism. You said there were 17, possibly?
No. This is the number of seconds in the universe,
Right.
but it's going up. That's all this 17 is.
But,
Yeah.
but you said Along with gravity, there's electromagnetism.
There's four forces.
Okay.
Four fundamental forces: gravity, electromagnetism, and then what they call the weak and the strong force. And those are subatomic forces. You know, like you have an atom, what holds an atom together, that's called the strong atomic force. And that's not gravity, that's not electromagnetism.
Now, electromagnetism and gravity related?
No, no. Electromagnetism and gravity are not related. That was his question.
The forces like for instance gravity, like we don't actually know why matter has gravity. We know that matter does have gravity, right? So the more mass, the higher the gravity.
No, the more like the force of gravity is always the same, but the more mass something has, the more like they're affected by gravity.
They're affected by gravity, but we don't actually know why, like gravity.
We don't know what it is.
We don't know what it is, and we don't know why. So I even think it's kind of crazy that we have gravity. Like, right, if you even just think about that. No, forget the probability of like, what if gravity was off by this? What are the chances that we even have a magical force that is a glue that holds the entire universe together? Like, think about
I'm
that.
not even talking about those. Like, cause
Right, that's crazy in itself that we
this
have
is
this
just
magical thing.
These is just like these constants and amounts. Like we're not even like we're giving the physical laws.
Right.
Like why are the laws of nature even there? Like why do even they operate the way they operate? And this is something.
It's so insane that we have this glue that holds the whole universe.
You know, and it's the same thing with like evolution. Like evolution operates under certain laws. Like those laws didn't evolve; the laws were just there. So like, where then do these laws come from? Like, why do they work the way that they work? Why does the law of gravity work the way that it works? You know?
Let's figure it out.
Yeah, I don't know.
Does this question about gravity have anything to do with the Higgs boson?
No, that has to do with mass.
Well, I always thought that mass
I mean,
determined gravity.
the way that they sort of think. I mean, I'll try to explain this the best way I can. Like, imagine space itself is like a fabric. Like, actual physical space is a thing. So there's no such thing as like empty space. Like, space is a thing. And like, there's this good video on YouTube, which I should bring up, that comes this bowling ball that shows. So then if you put something that has mass, it sort of indents that fabric. And then when you add other things, like if you're holding a piece of fabric and you put a bowling ball, it indents the fabric. And then other things that are smaller are then going to move around. So they almost think that gravity isn't really a force, it's just a disruption to space-time. So it forces these things to move. So that's why, like, and he illustrates it well with pool cues and bowling balls, and they do actually spin. So like the Earth has like sort of disrupted the fabric of space, and so that's why the moon can't get out of this indent. So it's sort of just like spinning around in this. And if you do it with a piece of fabric, they spin the same way. You know, it's much quicker than it happens in reality. Like, you know, you put a bowling ball in a piece of fabric and spin it, and then you put a marble, the marble's going to do 3 turns and be there. But imagine that on a much bigger, slower scale, and that's how they sort of think it works. You know, and then you have galaxies themselves that are sort of taking up this indentation in space. So that's sort of that's the best theory on how it works. But like why it works that way, I don't know.
It's a little too magical.
The other thing is, I said like we have this known observable universe, is that we only actually observe 95% of it. I mean, 5% of it. 95% of the universe is like unseen, like with what's called dark matter and dark energy.
We don't know that it has meant to be.
As we know it, yes. Like it's either it's not going to collapse. There's not enough mass in the universe to force it to collapse. So it's basically just going to expand into thermal death. Like it's going to run out of heat, and eventually the universe is going to run out of heat, and all atoms and electrons are going to lose their power and energy, and everything's just going to sort of freeze. That's take it to its scientific end.
When you say it's expanding, what do you mean by expanding?
So, actual physical space is expanding.
So how can it not be infinite?
because like we know that there is an end to what we know of as space. Like, so if you go beyond the observable universe, there's no like physical space there. We don't know what's there. Yeah, like if it was already infinite, it couldn't expand. You know, the universe is expanding. If it was infinite, it wouldn't be expanding. It would already be everywhere. It's hard to conceive of these things.
I look at it different, like you say, expanding, it's got to go somewhere. So it's got to go into that, so it's got to be more.
So you
There's gotta be
think
more.
of this.
There's got to be more, right?
But it's not space. Like what we know of as space, like the space between you and me is actually a thing. Like empty space is a thing. Like, so it's not expanding into more space, it's just expanding. Like physical space is expanding. Like what's beyond the universe is, like I said, it's like nothing. We don't know what it is. It's like nothing. There's no space beyond the universe that we know of, but it's expanding. Yeah. The balloon illustration isn't even an accurate illustration. It's just the best one to use. Like,
Space is expanding into
yeah, space and time are expanding into,
non-space.
like, we don't know. Yeah. All right, I'm it. My brain's fried.